Alright, in this video I'm going to explain how composition of functions work. Okay, and you're going to perform operations on functions next, so that's our eventual goal. So we're given two functions, f of x and g of x, they're shown here, and we're asked to find the following. I'm going to add a bonus to this. After we finish finding out what this is, we're going to find the domain of that function. Okay, so the notation might be new to you. The way we would read this is f composed with g of x. So that little circle there, it almost looks like a little degree mark. That means f, that's the composition symbol here. And you can see it over in b as well. So it doesn't mean multiply or anything like that. It's an open circle. So this is f composed with g is how you can say it, or f composed with g of x. And so sometimes I write it like this, or you'll see it written like this. And this, to me, is kind of the easier way of seeing it. But basically what it means is we're going to write the function f, and we're going to replace every x with the function g. So g of x kind of goes inside the function f. That's how we would do f composed with g of x. And the reverse would be true over here. And note the different notation. It actually is going to mean the same thing, so you could say either way. And then we'll look at examples where we actually plug in a number. So g of x comes second here in this. So if I change the order around like I did here, the order will be different here. So what I'm going to have is g of x is 1 over x, and I'm going to plug in 1 over x every time I see an x in the function f. So the way that's going to look is like this, f of g of x equals, so we're going to write the shell of the function f, and I'm putting parentheses every time I see an x. So this is f of x without any x's filled in, and instead of an x there, it's going to be g of x. So g of x actually gets replaced there. I can actually write g of x there. All of these just become g of x. Now this is a skippable step, all right? So let me try to zoom in on that. But you could skip this step in the future, because you'll start to see, like, I don't have to write g of x each time. You can just write what g of x equals, which is 1 over x. But while we're learning it, maybe it's easier for you to see what happened there. Where did the 1 over x come from? Well, that is g of x. So that's how you would write it. And then we could simplify a little bit. So if we were to square this fraction right here, we would square 1, and we would square x. So 1 squared is 1, x squared is x squared. And then we would multiply that times 3. So we're going to end up with 3 over x squared plus 2 times this would be 2 over x plus 5. And that's good enough for now. We can just stop there. So this would be the same, this is the same thing as the original, right? So this is our function. If I wanted to find the domain, which I will ask you to do, of f composed with g, what I would do is the same thing I had done before with different functions. So I would look at this and I'd say, well, there's some fractions here. What values of x are going to be an issue here in the real number system? And so since there's these denominators, the only x value that's going to be an issue is 0. So we would just write like this. Same strategies we've used before. X cannot equal 0 in this composition of these functions. Okay? And then we'll just keep moving on. Same concept here, except the roles are reversed. So we've got g composed with f, and we could write that out like this, if that makes it easier for you. Okay, what does that equal? Well, we have the shell of g of x, which is just 1 over x. Now what goes instead of x? F of x. So what is it going to be? F of x is 3x squared plus 2x plus 5. So that is g composed with f. And notice I'm switching between the different notation. This means the same thing as this. I find this one easier, but that's just me. And if I wanted to find the domain of that, domain of g of f, g composed with f, I would look at, again, I'd see a fraction, I'd say, well, the denominator better not be 0. So I would want to look for when 3x squared plus 2x plus 5 is 0. So when is, in other words, 3x squared plus 2x plus 5? I don't want that to be 0, because then I'd be dividing by 0. And looking at this quadratic, I don't think I can factor this one. Are there two numbers that multiply to 15 but add to 2? No. So I would use the quadratic formula. I don't want x to equal the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And I would get x cannot equal the opposite of b plus or minus the square root of 4 minus, let's see, 60. So that would be negative 56. Okay, and this is 6. All right, so if I continued with this process, I have a negative under the square root, which is going to give me an imaginary number. So this quadratic has imaginary complex roots, meaning it doesn't cross the x-axis, because what's underneath the square root, it's actually called the discriminant, that is less than 0, meaning I'll have an imaginary number. So I could continue this process, but it's going to be a non-real number. So our domain for this is just, the domain is all real numbers. All real numbers are fine, because no matter what I plug in for x here, I'm going to get a positive value. I'm never going to get a I'm never going to get a 0 as the output, which would be the problem. 1 divided by 0 would be bad. All right, there we go. Going to keep on moving, plowing forward here. We got some numerical examples, which is good. So same exact idea as before. We've actually already done g composed with f of x, but now we're going to plug in a 3. So it's the same exact thing as I just did in the previous example, except now what I have is g of x, and instead of it just being f of x down here, it's going to be f of 3. So f of 3 goes there. Well, what's f of 3? So f of 3 by itself is just, I should probably put this all together because it's just a 1 over. 1 over f of 3 is 1 over, so we have to look at the function f and realize that the function f is 3x squared plus 2x plus 5. So I'm just going to plug in the number 3 every time I see an x. So that's 3 times 3 squared plus 2 times 3 plus 5. And then I simplify that. So that's going to be 3 times 3 squared is 9 plus 6 plus 5. That's going to give me 1 over 27 plus 6 plus 5. That's going to be what? 33, 38. So 1 over 38 is my final answer. So this is a numerical example. You take the number, you plug it into f of 3, you take that answer and plug it into g of x. That's another way of doing it. So you could start off by finding f of 3, get 38, and plug that into g of x. I've seen people do that in a few different ways. All right, that's how you would plug that in. Let's do one more. Here we're composing f with f. So it's the same exact idea, it's just kind of weird. Oops, not an x, a 2. So what we do is we plug in, we want to know what f of 2 is, right? So let me do it the other way so that you can see a different way of thinking about this. Maybe you want to figure out f of 2 first. Well, what's f of 2? That's the function f of x, and every time you see an x, you plug in a 2. Should remind you of some previous units that you've done. So this is 3 times 4 plus 4 plus 5. So that's what? 12 plus 4 plus 5. So that's what? Let's see here, 21. Okay. So then we're doing f of 21 because it was f of 2 is 21. So now we're plugging in, if it's f of 2 and f of 2 is 21, then we're doing f of 21. And this one is going to be, I'm going to need a calculator for this. I've got this worked out on the side, but same exact idea. It's just going to be a bigger number. Same exact stuff. Nothing fancy. When you plug it all in, you get 1,370, according to my calculator. And so f of 2 equals 1,370. All right. All right, so now there are some bonus questions that you will have, but that's kind of the basics to get you started. Certainly hope that helps.